this video, we will discuss about data logging. Data logging is the ability of TBox to record data. There are two ways of recording data: chronologies and sampling table. Chronologies constitute recording on event, so the variation of the tag will determine the moment when the tag is recorded. So if we speak of digital tag, it's the changing from 0 to 1 or the changing from 1 to 0. You decide which event you want to record, variation from 0 to 1 or variation from 1 to 0. You can define that for each tag individually, of course. The analog chronology, it corresponds to a variation in the value. So we have a reference and we define a variation based on this reference. So if we change plus or minus a certain delta from the reference, we do the recording of the data. This recording becomes the new reference. So if there is a variation up or down for the same delta, we do the recording, and so on. Let's take a look to numbers. So digital chronologies and analog chronologies, each record will consume 12 bytes. We can record maximum 32,000 records, and we have a total memory available for that of 768 kilobytes. In TwinSoft, you define the size of the number of records into the RTU properties. You have here digital chronology 100 record, analog chronology 100 record. Recording is based on the FIFO principle, first in, first out. Let's take a look to sampling tables now. So sampling tables is periodical recording. So you define a period between recording, and each time the period happens, data is recorded, whichever value it has. The principle of recording is also FIFO, first in, first out, and here also you define a size which corresponds to a certain period of time of recording. The value that you record can be a minimum, a maximum, an average, an instantaneous or an incremental based on the period here. We will see that in details when we do the configuration. Let's take a look to some numbers. So it's a periodical recording. So the minimum interval is 1 second. The maximum is 1 each month. Each tag is recorded into a separate table because we only record values. So the size of a record depends on the tag you are recording. It's either 1 or 2 or 4 bytes. And for each table, we record the period of recording and the last timestamp. Each time a new record is done, this last timestamp is refreshed. Now, when the data needs to be generated in a report, for instance, or for an HTML page, the time is rebuilt based on this last timestamp and period. So thanks to that, we consume very little memory. So we have 1 megabyte of memory, which can be expanded to 4 megabytes, but this constitutes hundreds and thousands of records. Let's go to TwinSoft and start with the digital chronologies. So in those folders here, we will define which tag we want to record, and whether we want to record them on event, we put them into chronologies. If we want to do periodical recording, we will put them into sampling table. So imagine that we want to record the door opening and closing from our water tower. So I select the tag door. I select which event I want to record, whether it's rising, opening, falling, imagine closing the door. Imagine I want also to record the pump. I want to record my pump activity. When does the pump start and when does the pump stops? You can define like that as many digital tags as you want. Now, regarding analog tag, imagine you have a pressure which pressure sensor 0.25 bars, and you have an average pressure of, let's say, between 8 and 10 bars. But if suddenly you have a very important changing of pressure, very high or very low, a drop of pressure, you want to record this event. So let's first make a tag for the pressure. So I go into my simulation card, analog input. I still have two analog input free. So I just click this one and I call pressure. And it varies from 0 to 25 with a resolution of 0.1 bar. Okay. This tag, I will declare it into chronology. At the chronology, I select my new tag pressure, and I select a variation of 5 bars, up or low. Okay. Okay, that's it for chronologies, but like that you can also define as many digital and analog tags. Let's take a look to sampling tables. So in sampling table, we define also a tag. So imagine that we have the level in our water tower. I want to record this level each, let's say, 15 minutes. You see, you can, on this period, have the min, the max, the average, or the incremental. So in fact, TBox record each second. So it means that after 15 minutes, I will have 900 samples. And on those 900 samples, it will give me the min, the max, the average, or the incremental. Incremental, we will see after. It's the difference between previous record and current value. So let's take the average. Then you select a size, or you can do a period, because you know the period here. So you can say, I want to record during 2 days, or let's say I want to maintain 7 days in TBox. So this corresponds to a size of 672 records. The maximum number of records is 65,535 per table. And you can define, okay, this is one table. You can define maximum 2,000 tables, then 2,000 tags. Let's define another sampling tables, for instance, with our electrical meter. So imagine that I want to record the power consumption, the maximum power consumption based on an hour. So I go to sampling table, I select the tag, emitter active power, I select a period of 1 hour, and I select incremental. So I will have a consumption based on 1 hour. And here again, I want to store 7 days in TBox. Okay. We will send this to TBox, but in order to see something quicker than waiting 15 minutes or 1 hour, I will define another sampling table with the tag seconds. Remember, we have defined some time variable here, so we have the second in TBox. And I will define, for instance, average each 10 seconds in the size of 1,000 records. Okay, so it means each 10 seconds I will have a recording of sampling table in TBox so that we can see something already. Okay, so let's send this to TBox and test it. Once our TBox has restarted, let's see what data it has recorded. So remember that Chronologies is recording on event. So as long as no event happened, so nothing will be recorded. To see what is recorded, we can display here in communication menu. We have the access to the digital chronology table, the analog chronology table, and each sampling tables. So if I go to digital chronology, nothing to show. So I need to activate the tags recorded into chronology. So the door and the pump. So the door, I can simulate a door entrance. and I go to retrieve digital chronology, and I see the door is effectively open. I will close the door. Well, this window does not refresh automatically. I need to close it and open it again. But it's just a tool to check it works. Okay, and it works. It is recorded. My pump is at the moment active, so I will stop my pump. Sorry, my pump is here. Remember F4 to start and stop. Start again. So if I go to communication, retrieve digital chronology, I can see my pump has been stopped and started. Okay, analog chronology is this pressure information with a variation of 5. So if it varies less than 5, above 10.4, or below 9.4, sorry, so nothing will happen. So communication, retrieve analog chronology, nothing. If it goes above 5 units above 9.4, then it will be recorded. This 15.4 becomes the new reference. If there is a new variation of 5 units above 5.4 or below 15.4, it will be recorded. Let's take a look to sampling tables. So remember, sampling tables is periodical recording, whichever value it has. So our water level is a recording each 15 minutes. So if I retrieve sampling table, there is nothing to show because we haven't passed 15 minutes yet. If I go to the second sampling table, remember here we do recording each seconds. So I do communication, retrieve sampling table number 3. Here I see records each 10 seconds. And note that TBox does the recording on the birthday time. So if you select a period of 10 seconds, it will be each round 10 seconds. 0, 10, 20, 30, and so on. If you do recording each hour, it will be each round hour. And here we see the average of the seconds on a period of 10 seconds. So the average between second 0 and second 10 is second 4, and so on. Let's take a look to the memory consumption of this data logging. If I increase the compilation window here, I have information about memory usage. TwinSoft will prepare the memory for TBox. So it means that during compilation, TwinSoft will check whether there is enough memory in the TBox for the configuration. So here we see we have 1000 bytes for analog digital chronology, 1000 bytes for analog chronology, and around 4000 bytes for sampling table. So, and we have a total of 1 megabyte here, and we still have 965 and so on. So if I increase, for instance, the digital chronology to 1000 records each, and I compile, so this is button to compile, I see that now the size has increased. Okay. If I increase the size of second here, I put 65,535, which is the maximum. Look at this number here. Okay, it has increased. You see, it has passed to 68,000. So TwinSoft, during compilation, make sure that the memory is sufficient in TBox. If there is an error, a red message will appear in the list indicating the error. Let's go back to Chronologies to look at some advanced settings. So you might have seen in the Chronologies we have a handling configuration. By the way, this handling configuration is also something available in alarm conditions. Okay, if you remember alarm condition, we also have this kind of handling configuration. Okay, let's go back to Chronologies. Handling provides a supplementary condition for recording. Enable means always recorded. Disable, never recorded. Power failure concerns the handling of a backup battery connected to TBox. The backup battery will provide power to the system when the main power failure breaks down. In such a case, the data will not be recorded when the system runs on the battery. The recording can also be disabled manually with the help of system variables. Let's take a look to the power failure, how we can handle the power failure. So for this, we have to go to our resources and to our power supply. So I have an MSPS 230 volt. When I look into the IOs, I have a tag power failure. This suppose I have cabled a backup battery to my power supply. Then I will just tag this one. When the main power will breaks down and the system will run on the battery, this tag will change to 1. Now I have to inform the system of this power failure feature, and for that I have to go into the RTU properties, advance, start stop, and there I have power fail, and then I have a power fail tag, and there I declare my power failure tag. So the power failure mechanism is now handled by TBox. And if in my chronologies I select that, for instance, the pump, I don't want to record the pump activity in case of power failure, I just select this. Now, let's take a look to the other condition, which is the system variable disable CRD or disable CRA. So we go to the system variable, digital, disable chronology digital, disable chronology analog. So those system variables, you can handle them manually. Imagine you do a maintenance on the site. So if you do a maintenance, you will stop the system, and you don't want those events to be recorded. So when you go to the site, you push on a button, maintenance button. This button will raise those two system variable, and you will do that with the programs, okay, with the PLC programming. When those tags are changed to 1, the recording will not be done. So let's imagine that, for instance, the opening of the door, you don't want to record it when you do the maintenance, because if you do the maintenance, you will enter the site, you will open the door, you will close the door. So you set the handling to disable CRD-CA, and it will not be recorded when you do the maintenance. This handling of the maintenance could be handled by the PLC programming. So if I press on the button maintenance, I disable recording into chronologies. Now that we have logged data in TBox, let's see how we can use this data. So I open this document about the training. So TBox is able to push data. So data can be pushed in different format. There is a proprietary format which is a binary format, and this format can be handled by TView. TView is a data aggregator oriented for TBox, and it allows to display this data in chart or in tables. Data can also be sent in a report in either CSV or XML or JSON format. This also would be handled by an external proprietary software that you would develop. In terms of standard protocol, TBox support IEC 6870 and DNP3, and those protocols have their own stack of events. Then we have OPC UA also, and OPC UA use the chronologies and sampling table. This is for push technology. Then TBox support also the classical pull technology. So in pull technology, data can be retrieved, for instance, in a web form. So the web form is what is used to build HTML pages. So we can display historical data in HTML pages. We provide HTTP APIs, so you can develop your own software using HTTP protocol to collect data in TBox. TView was mentioned before. TView can also collect data in TBox. In terms of standard SCADA, well, because the way of recording data is not standard, our own way, I mean chronologies and sampling table, downloading data with a standard SCADA require a special drivers. These drivers exist for some of the SCADA on the market. This driver is developed based on a library we provide, which is called TCOM, and this library allows to develop any Windows drivers to collect data in TBox. And you can develop either in C, C++, .NET or VB. Talking about standard protocol, IEC and DNP3 support also, of course, polling data as well as OPC UA. This ends this video about data logging. Let's take a look to the questionnaire. The question for this video, so use always the same application as usual. If you have a power supply MS PS 230 volt, you create the tag power failure from its resources. If you have an MS AC 30 watt, you create an internal digital tag that you name power failure. Declare this tag power failure in RTU Properties Advanced tab power failure. From the MS IOSimul, create a third input named pressure with a scale of 0 to 25 and a resolution of 0.1. Declare digital chronologies for the tag door and pump with a handling of power failure for door and a handling disable chronology for the pump. Define analog chronologies with the tag pressure with a variation of 5. Define 3 times sampling tables with the tag tank level, with the tag power and the tag second with this configuration. Send to TBox. Download chronologies and sampling tables that you can see values. Of course, after you have sent the TBox, you will have to change tags for chronologies in order to see the changing. Remember, chronologies is on event. Take snapshot of the Windows chronologies and sampling table you have displayed and send application and snapshot. Good luck. The question for this video, so use always the same application as usual. If you have a power supply MS PS 230 volt, you create the tag power failure from its resources. If you have an MS AC 30 watt, you create an internal digital tag that you name power failure. Declare this tag power failure in RTU Properties Advanced tab power failure. From the MS IOSimul, create a third input named pressure with a scale of 0 to 25 and a resolution of 0.1. Declare digital chronologies for the tag door and pump with a handling of power failure for door and a handling disable chronology for the pump. Define analog chronologies with the tag pressure with a variation of 5. Define 3 times sampling tables with the tag tank level, with the tag power and the tag second with this configuration. Send to TBox. Download chronologies and sampling tables that you can see values. Of course, after you have sent the TBox, you will have to change tags for chronologies in order to see the changing. Remember, chronologies is on event. Take snapshot of the Windows chronologies and sampling table you have displayed and send application and snapshot. Good luck.